using test equipment and test methodologies. Then you put them together, and we start out in the first project. All they have to do when they finally get it all together is have it go straight and make some different shapes. So they have to turn the motors on, but it's all going forward. Now they're halfway through project 2, and their car has to go straight for a second and then go in reverse for a second. Can you demonstrate?
Yeah. I don't think I set it up to do a second exactly. But
That's
Power of 2.
so right now they have them, so it's going forward and reverse. And obviously when it got to where it was going to go in reverse, we didn't see magic smoke, so he's got that going right now. The next step is the square that you're standing in. He's going to put his car down in that square, between the square and the circle. And it can't leave the big square, and it can't enter the circle. And so he's going to have a detector, an IR emitter and detector, that has to detect the presence of that black line. And as soon as he hits the black line, it has to either back up or go in a different direction. So the object is now he has to start doing control theory and interfacing between. So he's got timers that are controlling his motors on and off, keeping them going correctly. And he also has to be reading an A to D converter to detect whether or not, am I hitting the black line? Am I off the black line? Where am I at? So it has to stay in there. Then we sort of take a departure. Like I talked to you about distributive, architecture and distributive systems. A GPS module is a embedded system. The one we use has an on core. And they're going to have to interface their car to this GPS module and communicate. And then they have to go out and get coordinates just like a regular GPS module and display them on their display. After they've done that, they get to the last project. And they have a choice. I go and set Coke bottles up on the deck, and they get to take their car to each Coke bottle and get what the GPS coordinate is, and they then have to navigate from one Coke bottle to the next around the course to get back, using the GPS to navigate by. Or they have the choice of following the curvy black line you sort of see on the floor. Now, the actual course that they do for a grade, we have set radiuses that they have to go around. And it's interesting because the smallest radius is 4 inches. The largest radius, I think, is 20 inches or 24 inches. But about 12 to 15% of them, no matter which way they start, from smallest to largest or largest to smallest, get to the 10-inch radius and the car goes off the track. So you start seeing how the control theory plays a role in how you're deciding what to do. And for the students that see it, first of all, for the students that their cars go off the 10-inch line, it's devastating because they're sitting there trying to figure out, it works on everything else, but it doesn't work on the 10. Their algorithm worked, but why is it not working at that? So they're pulling their hair out trying to get to work. But the other students in the class get to recognize that you can't just have an algorithm that you think works in one condition. You have to think about all the potential conditions that it has to be in. And so the object is that, so through the course, you have to do that, plus there's a document that they have to generate that they have to treat this as if they're trying to sell this car to a VC to get funding to market. So they have to take ownership and do a document and generate the information, because as engineers, we don't sell cars, we sell paper. And they need to understand how to generate that paper effectively to get someone interested in buying it.